Hi everyone, we're the systems team, and today we're going to be talking about our Sprint 1 presentation. My name is Sarah Downs, and I'm an electrical engineer.
I'm Tom Hopkins, also electrical engineer.
I'm Alec, I'm an ECE.
I'm Blake, I'm an ECE also.
My name is Matthew, and I'm also EE.
So this is our general brainstorming plan. The first step of our sprint was to visit the racetrack and develop a mapping system. We started by sketching the whole racetrack, and that'll help us design our mapping system, our measuring system, and then we obtained basic overall boundaries and measurements of the entire racetrack. This allowed us to brainstorm and come up with different ideas of how to map the track. We could map it in sections like shown in this picture, or we could come up with an entirely new idea.
All right, the first step of getting the racetrack into a program was to actually draw the track. So we sketched the racetrack outline. We labeled all 7 POSIX anchors that were on the track, and they're labeled 1 through 7 as seen on the screen. They're noted as X's, and we measured a few key distances from the boundaries. The boundary on the bottom side is the pool. It's the wall of the pool, but the top one is actually a red tape that we use as reference. And the bars that you see throughout the track are the locations of the start and stop of each turn sequence. We decided to document those as well because they could be important to determining how the car is going to behave.
Yeah, and then we actually had to decide how we were going to take our coordinate measurements for the simulation team. So we went through a couple of different iterations of this measurement method. One of them involved using a string to create the 2 X and Y axes. We also thought about doing the boxes and then going from there and taking coordinate systems from that. We ultimately decided to tape out an X and Y axes on the physical track and then use 2 poster boards that walked along those axes and a laser measurement device, which would be held at each coordinate point to actually take the measurements of each coordinate point on the track. This led to part of the system, or the Excel sheet that you see on this page. Those are the coordinates that we measured for the outside track of each quadrant. And then we also have what the simulation team put together from our initial measurements. And then once we talked more to the systems team, they created this image, which shows exactly where our coordinate points mapped onto their simulation. The car is in the middle, but it would normally be in the between part of the track. And then we still have a few coordinates that we need to work out with the simulation team, but otherwise it seems to be an accurate representation of the physical track.
So as I said before, we decided to use a quadrant system. You can see where the quadrants are labeled in the bottom right corner there. The origin is about Tower 7. They were taken in the form of a series of points for both the inner and outer track loop, and when they're connected, the track is formed. Now that we have the simulated track, we now need to put it in POSIX, because this is what actually the car is going to be using to know where it is on the track. And we need to get that in POSIX.
Something like that. So for the POSIX testing plan, the goal is to test the preliminary functionality of the POSIX system and make sure that all the sensors will communicate with POSIX. So to do so, we'll start by setting up POSIX locally, which is just installing the software and launching it. Using preferably the system team's drawing or the software team's drawing of the system team's measurements inside of POSIX, scaling those inside of POSIX. Then we can move on to connecting all the sensors, which includes the anchors. Then you can calibrate all these anchors and calibrate the master anchor just using auto calibrate. The final setup for the test plan would be to see if the cars or the tags in the POSIX system actually communicate. So they'll actually use an XY coordinate system, and what we want to do is ensure that we are reading data properly from the tags, making sure that it updates accordingly onto the POSIX system.
Moving forward and carrying on to sprint number 2, we developed some other future-proof steps. One, we're developing a Discord channel for all the different teams to communicate more efficiently together, so the software, the hardware, and hopefully the systems can come together and combine better shared locational files. Data collection for the setup of POSIX, like Alec mentioned, we're going to do more with the tags and working with the existing floor plan. refining measurements, verifying the accuracy of the existing data, just really running through the code and the software, making it the cleanest and most efficient look and layout of the track. And then just being able to share and communicate our findings and progress, and continue with the documentation and developing more efficient templates to report to.